Welcome to Learning Path 7, Design and Implement a Dependency Management Strategy. In this learning path, we'll take a practical tour through how modern teams handle dependencies end-to-end. We'll start by exploring what package dependencies look like in real projects, then dig into package management fundamentals talk about how to migrate, consolidate, and secure our artifacts. From there, we'll put a sensible versioning strategy in place and wrap with an introduction to GitHub packages so we can publish, consume, and govern packages confidently. Along the way, you'll see everything you need to make dependency management reliable and repeatable in your pipeline. Dependency management of modern software development ensures that the building blocks of an application fit together seamlessly. Modern software is rarely built by a single team from scratch. Instead, it's assembled from various components, often created by different teams or even external sources. This approach, known as component-based development, means software projects rely on packages and modules maintained by others. Dependency management is the practice of tracking, organizing, and updating these components so that our software remains stable, secure, and easy to maintain. A dependency management strategy is essential for modern software development because it brings order and predictability to how teams handle the libraries, packages, and components that our applications rely on. At its core, this strategy involves standardizing how dependencies are managed, choosing consistent package formats and sources, and implementing clear versioning practices. Standardization means everyone on the team follows the same rules for adding and updating dependencies, which reduces confusion and minimizes errors. Identifying dependencies in a solution means finding the components and source code that can operate independently within a system. This means looking for parts of our application that can be deployed, released, or versioned separately from the rest. When you spot these independent pieces, you gain flexibility. Updates or changes to one component don't have to disrupt the entire system. To do this effectively, consider how often each component changes, whether those changes are unrelated to other parts of the system, and if the package can exist on its own. The goal is to ensure that each package adds value for others, making our software more modular and easier to maintain. Componentization is a powerful approach in software development that helps teams organize our code bases for greater flexibility and maintainability. Source componentization means splitting out different parts of our application into separate components or projects, which might live in different solutions, and this makes it easier to manage, update, and reuse code since each component can evolve independently. Package componentization takes this a step further by composing our solution to use packages, pre-built units of functionality that can be shared across projects or even teams. By leveraging packages, developers can avoid reinventing the wheel and instead focus on building new features, knowing that reliable components are already available. Decomposing our system is all about breaking down a complex application into smaller, manageable pieces that work together smoothly. The process starts by drawing a dependency graph. It's a visual map that shows how different components rely on each other. By grouping related components into sets, teams can assign responsibility more clearly and ensure that each set follows a shared release schedule. This approach minimizes the number of changes that span across different sets, making it easier for teams to coordinate updates and maintain stability. Ideally, a single team oversees each set, which streamlines communication and accountability. So what we end up with is a clear map of our code that shows functionality that could be converted into a shared library or package. Now that we have a package, we need to know what to do with it. And for that, we move into understanding package management. Package managers are specialized tools that help developers find, install, and manage these packages efficiently. Some of the most widely used package managers include NuGet for Microsoft and .NET artifacts, NPM for Node.js modules, Python's pip for Python modules, Maven for Java, and Docker for container images. Each manager is designed to work with specific programming languages or platforms, making it easier for teams to integrate reliable, pre-built components into our applications. The use of package managers streamlines the development process by automating the retrieval and update of dependencies, ensuring that projects always use the correct version of the libraries and tools. This not only saves time, but also reduces errors and compatibility issues. Package feeds are centralized storage locations for software artifacts. We can think of them as organized libraries where developers can find, share, and manage reusable code components. These feeds can be public, like NuGet.org, npmjs.org, or pypy.org, or Docker Hub, which are open to everyone. Or they can be private, such as MyGet, Azure Container Registry, Azure Artifacts, and other self-hosted solutions. These offer secure access for specific teams or organizations. By storing packages in these repositories, we ensure that the right versions of the dependencies are available and can be managed efficiently, reducing the risk of compatibility issues and streamlining the development process. The benefits of using package feeds are substantial. They provide version storage, and every update or change to a package is tracked, making it easy to roll back or update dependencies as needed. Managed by specialized tools, these feeds help automate the retrieval and installation of packages, saving developers time and minimizing errors. As a package feed manager, your job is to manage feeds. Think of these as organized storage spaces for software packages. Developers search and list packages from the feed, making it easy to find what they need. Consuming packages is a core task. You help teams install and use the right packages for their projects, ensuring everything is up to date and compatible. Maintaining a local installation cache is also important, as it speeds up the development by keeping frequently used packages readily available. Publishing packages is another key responsibility. You'll make new or updated packages available to others, supporting collaboration and reuse across teams. And finally, choosing the right tool is essential. Whether it's command line tools or integrations with build and release pipelines, the right tools streamline every aspect of the feed management and keep our development process running smoothly. Software development teams will then rely on public package sources to find and use pre-built components, libraries, and tools. These sources act as vast repositories where developers can search for packages that suit their project needs. Some of the most popular package sources include NuGet Gallery for .NET libraries, npm.js for JavaScript, Maven for Java, Docker Hub for containers, and Python packaging index or PyPy for Python modules. Each of these platforms is tailored to a specific language or ecosystem, making it easy for developers to discover, install, and update packages directly from trusted sources. So our software teams often need to store and share a package, the bundle of code and resources across our projects. There are two main ways to do this. We have self-hosted private feeds and software as a service private feeds. Self-hosted feeds are managed on our own servers. It gives us full control over security and customization. So for example, I can install a NuGet server for .NET, Sinopia or Verdaccio for NPM, Nexus for Artifactory for Maven, Portis or Harbor for Docker, and PyPy server for Python. These are all self-hosted solutions. These are ideal when we need strict control over our environment or we want to keep everything in-house. On the other hand, software as a service private feeds are managed by third-party providers in the cloud, offering convenience and scalability. Examples of those would be Azure Artifacts, MyGet, GitHub Packages, Docker Hub, and Amazon Elastic Container Registry. These services handle infrastructure, updates, and security for us, making it easy to collaborate with our distributed teams and scale as our needs grow. Consuming packages is the fundamental step in the software development cycle. This is where teams leverage pre-built components to accelerate our projects. The process begins by identifying a required dependency for our codebase, essentially figuring out what functionality or library our project needs. Once we know what we're looking for, we search for package sources like NuGet, NPM or Maven or PyPy to find the package that offers the right version and features. After selecting the best fit, we install the package into our development environment and codebase, making it available for our team to use. This step is crucial because it ensures that our software is built on reliable, tested components rather than needing to investigate each package every time. Azure Artifacts is a powerful service within Azure DevOps that lets development teams create both private and public package feeds for a variety of package types, including NuGet, NPM, Maven, and universal packages and Python packages. We can think of it as a secure, centralized hub where our team can store, share, and manage reusable components and libraries for our projects. By using Azure Artifacts, we can control who has access to our packages, ensuring that sensitive or proprietary code is only available to the right people, while still enabling broad collaboration when needed. Publishing packages is a crucial step in our modern software development, especially when working with Azure DevOps and Azure Artifacts. From Azure DevOps Portal, we can create centralized feeds to host and control permissions for our packages, and when publishing, we can specify important details like the feed's name, visibility, and ensuring that only the right people can access or contribute to our packages. We can also set public sources as upstream, which means our feed can pull packages from trusted public repositories, making it easier to keep our dependency up to date. Now let's talk about securing our packages. In software development, an artifact is any deployable component of our application. We can think of that as a packaged piece of code, a library, or even a container image that's ready to be shipped or reused. Identifying existing artifact repositories is crucial because it helps us keep track of where these components are stored, how they're managed, and which versions are available for deployment. Azure pipelines make this process seamless by supporting a wide variety of artifact sources and repositories, so we can easily integrate different technologies and tools into our workflow. Each release can specify exactly which version of the artifact is needed, ensuring consistency and reliability across environments. Securing access to package feeds is a critical part of managing software dependencies in any organization. Package feeds act as storage locations for reusable code components, and not all packages should be available to everyone. Private feeds restrict access to only authorized people can publish or consume packages, protecting sensitive or proprietary code from being exposed or modified by untrusted sources. This means that when a package feed is intended for a specific audience like your development team or trusted partners, access can be limited to those individuals, ensuring that only approved users can install the packages from that feed. In Azure Artifacts, roles help define what different users can do within a package feed, making it easier to manage and access responsibilities. The main roles include reader, collaborator, contributor, and owner. Readers can list and restore or install packages, which is perfect for team members who just need to use existing packages. Collaborators can save packages from upstream sources, allowing them to help keep the feed up to date, the latest versions. Contributors have the power to push new packages and unlist outdated ones, making them essential for maintaining the feed's quality and relevance. Owners have full control. They can manage permissions, rename and delete feeds, and handle all the administrative tasks. The project collection build service is set as a contributor by default, ensuring automated build processes can update packages as needed. While we review these roles shown in this format on this table, let's talk about how clearly defined roles streamline collaboration and security within our development team. So by assigning the right permissions, we ensure that only trusted users can make the changes to critical packages, while others can safely consume and update packages as needed. This structure helps prevent accidents or unauthorized modifications, supports compliance with organized policies, and makes it easier to audit who did what. Whether you're working in a small team or a large enterprise, using roles in Azure Artifacts keeps your package management organized, secure, and efficient. Authentication is a key part of working with Azure Artifacts, ensuring that only authorized users can access, publish, or manage packages within our organization. When you're logged into the Azure DevOps portal or running build tasks, authentication is handled transparently, meaning you don't have to manually enter credentials each time you want to interact with package feeds. For external package sources, such as NPM or other registries, we may need to set up service connections, which involves setting up credentials like username and password or an authentication token. This process helps maintain security by verifying that only trusted users and systems can access sensitive software components. Packages are versioned. So let's talk about versioning strategy. Versioning is a fundamental practice in software development that helps teams keep track of changes to packages and components over time. Each package is assigned a unique version number, which makes it easy to identify, maintain, and update as the software evolves. This is especially important because every package has its own lifecycle and rate of change. Some may be updated frequently, while others remain stable for long periods. By making clear versions, developers can ensure that their application uses the correct compatible components, reducing the risk of unexpected issues when new features or fixes are introduced. A key principle in versioning is immutability. Once a package is published, it cannot be changed. If any updates or fixes are needed, a new version must be created and released. This approach guarantees that previous versions remain available and unchanged, which is crucial for maintaining stability and reliability in our software projects. Immutability also makes it easier to roll back to earlier versions if problems arise, and it supports best practices for collaboration as teams can confidently build on top of well-defined, unchanging components. In short, versioning and immutability help teams deliver robust, maintainable software that can evolve smoothly over time. At its core, versioning is about assigning a unique identifier to each release of a package, making it easy to track changes and updates over time. The way that we express a version can vary depending on the package type, but most teams use a versioning scheme, like the familiar major.minor.patch format, for example, 2.1.15. This structure helps developers quickly understand the significance of each update. Major changes might introduce new features or break compatibility, minor updates add improvements, and patches fix bugs. By following a clear versioning scheme, teams can maintain order and predictability as their software evolves. Semantic versioning is a system for labeling software package versions in a way that clearly communicates the nature and risk of the changes. A typical semantic version, as we have seen, looks like 1.2.3, where each number represents a different level of change. But sometimes you'll see extra labels like Beta 2 that indicates the quality or stability of the release. This approach helps developers and teams instantly understand what to expect from a new version, making it easier to decide when and how to update their dependencies. In Azure Artifacts, views act as filters or stages that help teams organize packages based on their readiness and stability. The three default views, local, pre-release, and release, let us separate packages that are still being tested from those that are ready for production. For example, when a package is first created, it starts in the local view, where developers can experiment with it and make sure everything works. Once it's stable, it can be promoted to pre-release for broader testing, and finally to release when it's fully vetted and ready for use by everyone. Promoting packages is a key step in managing software releases within Azure Artifacts. When a package is first created, it typically resides in the @local view, where developers can test and validate its functionality. Once the package is deemed stable and ready for broader use, it's promoted to other release views, such as pre-release or release. This process ensures that only thoroughly vetted packages become available for production environments, reducing the risk of deploying untested or unstable code. Upstream sources are evaluated only from the @local view, and packages become visible in other release views only after promotion, which helps maintain a clear separation between development and production-ready components. A documented versioning strategy is the backbone of reliable software development. By clearly outlining how versions are assigned and updated, teams avoid confusion and ensure that everyone is on the same page when it comes to managing dependencies. Adopting SemVer 2.0, a widely recognized semantic versioning scheme, helps communicate the nature and the impact of the changes, making it easier to track updates, bug fixes, and new features. This clarity is especially important when multiple teams or projects rely on the same packages, as it prevents accidental upgrades or compatibility issues. Now let's take a look at GitHub Packages. GitHub Packages is a powerful platform designed to host and manage software packages right alongside your source code in GitHub. By combining code and packages in one place, it streamlines the development workflow, making it easier for our teams to share, reuse, and maintain components. GitHub Packages integrate seamlessly with GitHub's permission management and billing so they control who has access to the packages and track usage without juggling multiple tools. Plus, it works with popular registries like NPM, RubyGems, Maven, Gradle, Docker, and NuGet, supporting a wide variety of development environments and languages. Publishing packages to GitHub Packages is a streamlined process that leverages the native tooling developers already use for their programming languages. Whether you're working with JavaScript, NPM, which is NPM, or RubyGem, Java, which is Maven or Gradle, or .NET, you simply use your package client's standard commands to publish new versions. The process starts by creating or using an existing access token with the right scope. This token acts as your secure key for authentication. Once authenticated, you publish the package using your client's instructions, making it available for others to install and use. This approach keeps things familiar for developers and integrates seamlessly with existing workflows. Let's look at an example of publishing a .NET package to GitHub Packages. When publishing a .NET package to GitHub Packages, we need to configure the NuGet client to authenticate and connect to GitHub's package registry. This is done using an XML configuration file called the NuGet.config. The XML structure defines the package sources and credentials required for publishing. In the example, the package sources section lists GitHub as a source, pointing to the registry URL for the organization or user. The package source credentials section securely stores your GitHub username and personal access token, which acts as a password for authentication. This setup ensures that only authorized users can publish packages, keeping your code safe and traceable. Installing a package is a straightforward process that empowers developers to quickly add new functionality to our projects. The first step is authenticating to GitHub Packages using instructions specific to our package client. And whether you're working with NuGet for .NET, NPM for JavaScript, or another supported tool, once we're authenticated, we simply use our package client's commands to search for and install the desired package. This process is illustrated in the Visual Studio, where the developers can browse available NuGet packages and then add them directly to their projects with just a few clicks. Deleting and restoring packages in GitHub Packages is about maintaining control over our software artifacts. If we have the right access, we can delete entire packages or specific versions, whether they're private or public. For public packages, there's an extra safeguard. You can only delete them if no version has more than 5,000 downloads. which helps protect widely used components from accidental removal. The process is straightforward. Navigate your package's settings, select the version of package you want to delete, and confirm your choice. This ensures that only authorized users can manage critical software assets, keeping your responsibilities clean and secure. Package access control and visibility are essential for managing who can interact with our software packages and container images in GitHub packages. There are three main roles: read, write, and admin. Read access allows users to download packages and view metadata, ensuring they can use the package but not modify it. Write access lets users upload new packages and update metadata, supporting collaboration and ongoing development. Admin access provides full control, including the ability to delete packages and manage permissions, which is crucial for maintaining security and governance over valuable software assets. Let's go now to a demonstration of package management systems. Let's take a look at Azure artifacts. When we select Connect to Feed, it brings up all the feed options that we can connect to. Selecting a feed type brings up everything that we need to connect. We can see that each feed type has all the options for consuming and creating packages. Let's create a new feed. We'll give it a name and select the visibility and scope, and whether or not we allow upstream sources. Now let's add an upstream package from NuGet. We need the exact name. Let's choose Microsoft Cosmos. And look at all of our options for this package. Note the versions and information presented here. Back in Azure Artifacts, we simply add the full name, and we can see all of the options right inside of our interface. We use the vertical ellipsis to choose the version we want and save the package to our feed. Now that we have the package in our feed, we have all the access to the information about the package, and we can promote the package for release or demote or delete a package if we have the permissions. In the feed settings, we can set our package retention policies. We can also set permissions and create new views to show the quality of package versions, limiting who can access the new view, and we'll add beta for packages that we are developing. We can view and add upstream sources. If you'd like to go deeper and run the AZ-400 lab exercises using your own accounts and subscriptions, you can find the self-paced labs on GitHub at Microsoft Learning /MSLearn-DevOps. And if you prefer structured guidance, you'll also find options for instructor-led AZ-400 training with live labs and expert instruction on Microsoft Learn at the AZ-400 course page. This concludes our session. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.